Hello, my dear students. Welcome to Sankalp Learning Classes. Today, we are discussing the important question answer from the magnetic effects of the electric current. Yes, this video that will be helpful for your preparation of board exam. Okay, please, this 1 hour video that is very helpful to face the board exam because I have included the important question from the old question papers, model question paper from every old question paper. So that is very important thing I have to mention here. Yes, let us start with the first question before starting the question answer. So I just want to inform that here MCQs will be there. So I will discuss the MCQs, 1 mark, 2 mark, 3 and 4 mark questions. Okay. Yes, let us start with the first question. The magnetic field lines inside the solenoid are in the form of parallel straight lines. The reason for this is magnetic field inside the solenoid is option A, very high, option B, uniform, option C, zero, option D, produced by electric current. Here, the magnetic field lines inside the solenoid are in the form of parallel straight lines. The reason for this is magnetic field lines inside the solenoid is option B, uniform. The correct answer is option B, uniform. Next question. Observe the diagram. The magnetic poles represented by P and Q respectively are. Here, just see this bar magnet and the direction of the magnetic field lines. Here, so you can say that this is north and the south because always the magnetic field lines, they emerge from the north and they move towards the south. And here also you can see the direction like this. So this is north and this is the south, right? Here the magnetic poles represented P and Q respectively. Here P and Q are south S and the south S, north N and the south S, that is not correct. North N and the north N, that is also not correct. South S and the north N. So here the correct answer is south S and the south S. Option A is the correct answer. That is south S and the south S. Next question. Which of the following correctly describe the magnetic field near a long straight wire? The field consists of straight lines perpendicular to the wire. The field consists of straight lines parallel to the wire. The field consists of radial lines originating from the wire. The field consists of concentric circles centered on the wire. Here for this question, the field consists of concentric circles centered on the wire. The field circles centered on the wire. Next question. At the time of short circuit, the current in the circuit reduces substantially, does not change, increases heavily, vary continuously. Here, at the time of short circuit, the current in the circuit that increases heavily. Okay, the correct option is increases heavily. Next question. State whether the following statements are true or false. The field at the center of a long solenoid carrying current will be parallel straight lines. A wire with green insulation is usually the live wire of electric supply here. This is true. The field at the center of the long solenoid carrying current will be parallel straight line. That is true. And a wire with green insulation is usually the live wire of an electric supply. That is false here. green wire that represents the earth wire. Next question. Magnetic field is the quantity that has both dash and dash. Magnetic field is the quantity that has both dash and dash. Option A, magnitude and direction. Option B, magnitude. Option C, direction. None of these. Magnitude, magnetic field that has both magnitude and the direction. Option A is the correct answer. Next question. An electric current through a metallic conductor produces dash around it. Electric current, so that produces the magnetic field. In our country, the potential difference between two wires is option A 220 volt, option B 240 volt, option C 225 volt, option D 230 volt. Here, in our country, the potential difference between the two wires that is 220 volt. Next question. In right hand thumb rule, thumb represents option A, magnetic field, option B, direction of the current flow, option C, the direction of the magnetic field, none of these. In the right hand thumb rule, so it is like this right hand thumb rule. Here, the thumb represents, that is the direction of the current flow. The thumb represents the direction of the current flow. Option B is the correct answer. According to the Fleming's left-hand rule, thumb represents the direction of the magnetic field, direction of the current, force acting on a conductor, none of this here. In the Fleming's left-hand rule, the thumb represents the force acting on a conductor, and the middle finger that represents the direction of the current, and the index finger that indicate the direction of the magnetic field. Yes, this is the in Fleming's left-hand rule, the middle finger indicates the direction of the, yes, here, the middle finger that indicates the direction of the current, direction of the induced current. Okay, so here, here the correct option is the direction of the current. Here you can see the answer, direction of the current. So till now we have discussed the MCQ question, that is the multiple choice questions. Let us discuss the 1 mark questions. Okay. Yes. List 2 methods of producing the magnetic fields. Here, by using the magnet and by using the electric current, so we can produce the magnetic fields. Next question. When does an electric short circuit occur? When does an electric short circuit occur? Here, the insulation of the wire is damaged, there is a fault in the electric appliances, there is a chance of electric short circuit. Magnetic field lines do not intersect each other. Why? Magnetic field lines, they do not intersect each other because if they did, it would mean that at the point of intersection, there would be a two different direction for the magnetic field, which is not possible. Each point in a magnetic field has only one direction of the field. So the lines always remain separate and never cross. Next question. Suggest any two measures to avoid the overloading in domestic circuit. So how we can avoid the overloading in the circuit, domestic circuit. Okay. So what is the answer? Avoid connecting too many appliances to the single socket, or to connecting the too many appliances that can cause the overloading. And by using the fuse, we can prevent the overloading in the electric circuit. Okay. Next question. What does the thumb indicate in the right hand thumb rule? Yes, this question we have solved in the multiple choice question. What does the thumb indicate in the right hand thumb rule? Here, yes, the thumb indicates the direction of the current, and the remaining fingers, they indicates the magnetic field. Okay, so that is the answer. Next question. So next we are discussing the 2-mark questions. Okay. Here, observe the figure. So just mention the direction of the force acting on the current carrying conductor AB. Okay. Name the rule that help to you find the direction of the force. Here, the current is flowing in this direction from B to A, and it is kept in the magnetic field. So you have to find out in which direction. So there is a the force is acting on this conductor. Okay. So using the Fleming's left hand rule, you can detect this. Okay. So here the direction of the force, the rod, that is the current carrying rod, that is displaced towards the left. And here the Fleming's left hand rule, that helps us to find out this. Next question. What are the reasons for occurring overload in an electric circuit? Here, what are the reasons for occurring the overload in an electric circuit? Overloading can occur when the live wire, that is, and the neutral wire come into direct contact. When it occurs, this occurs when the insulation of the wires is damaged or there is a fault in the appliance. Overloading can also occur due to an accidental hike in the supply voltage. So that also occur due to the accidental hike in the supply voltage. Okay. Then an electric oven of 2 kilowatt power operated in the domestic electric circuit 220 volt that has the current rating of 5 ampere. What results do you expect? Explain. Here, what is the power, that is 2 kilowatt, means that is equal to 2000 watts, and voltage, that is 220 volt. The current rating, that is 5 ampere. Okay, so the capacity is 5 ampere. But let us check the current flowing in this circuit, P is equal to V into I. I we have to find out in this circuit, that is I is equal to P by V. Here P, that is 2000 watt divided by 220. 0 get cancelled. Then 2 ones are here, 2100 here, 11 ones are 11 nines are 99, 1 remaining. Then 0, we'll put the 0, 9. Okay, 9.09 ampere. So the current rating is 5 ampere, but the current flowing in this circuit, that is 9.09 ampere. So it is the current drawn by this electric oven is around 9 ampere, whereas the fuse in the circuit that is 5 ampere. So the fuse will get heated too much and melt and break down the circuit. What precautions should be taken to avoid the overloading? Should be taken to avoid the overloading of domestic electric circuit. Here, each appliance has separate switch to on and off to flow the current through it. The use of an electric fuse prevents the electric circuit and the appliance from the possible damage by stopping the flow of unduly high electric current. We should not connect too many appliances to a single socket to prevent the overloading. Okay, so these are the precautions should be taken to avoid the overloading of domestic electric circuits. Next question. When is the force experienced by a current carrying conductor placed in a magnetic field largest? If the direction of magnetic field and the flow of electric current are mutually perpendicular, then force experienced by a current carrying conductor in a magnetic field is largest. So that is the answer. Next question. State the rule to determine the direction of a magnetic field produced around a state conductor carrying current. Force experienced by a current carrying state conductor placed in a magnetic field which is perpendicular to it. Here, magnetic field produced around a state conductor carrying conductor, that is by using the right hand thumb rule. Right hand thumb rule. Then force experienced by a current carrying state conductor placed in a magnetic field which is perpendicular to it. So that is Fleming's left hand rule. Fleming's left hand rule. What is the function of an earth wire? Why is it necessary to connect the earth metallic appliances? Necessary to connect the earth for the metallic appliances. Here, this is used as a safety measure, especially for those appliances that have metallic body, for example, electric press, toaster, table fan, refrigerator, etc. The metallic body is connected to the earth wire, which provides a low resistance conducting path for the current. Thus, earth wire ensures that any leakage of current to the metallic body of the appliance keeps its potential to that of the earth, and user may not get a severe electric shock. List the properties of magnetic field lines. Yes, magnetic field lines are continuous curves that form closed loops. Magnetic field lines originate from the North Pole and end at the South Pole. Magnetic field lines are more crowded near the poles where the magnetic field is stronger. Magnetic field lines never cross each other. Is it possible to connect 1320 watt refrigerator to the 5 ampere rated plug in the 220 volt household electric circuit? Explain the reason for your answer. Here, power, that is 1320 watt, that is current of the fuse, that is the 5 ampere current, and what is the voltage, that is equal to V is equal to 220 volt. Okay. Then find out the P is equal to V into I formula. I is equal to P by V. Then I is equal to 1320 divided by 220. Okay. So here 11 ones are 2 ones are 11 6. The current flowing drawn by this refrigerator, that is 6 ampere, but the plug rated, that is 5 ampere. So here the fuse will blow. So this connection is not possible. Okay. Here, no, it is not possible to connect a 1320 watt refrigerator to the 220 volt household electric circuit with a 5 ampere fuse because the fuse may blow. Sorry. Draw the magnetic field lines around the bar magnet. Draw the magnetic field lines around the bar magnet, that you have to write. Yes, so these are the magnetic field lines around the bar magnet. Next question. What is solenoid? How can it can be converted into a electromagnet? What is solenoid? How can it be converted into the electromagnet? Here, by solenoid, that is insulated, and the yes, so that is coiled and insulated, that is connected to the circuit, that is called as a solenoid. How can it be converted into an electromagnet? Yeah, by passing through the electric current through the solenoid while it is wrapped around the ferromagnetic material. Next question. Observe the circuit diagram given below. Answer the questions given. Mention the direction of magnetic field that forms around at the points of X and the Y. Okay. Then State the rule that helps to decide the direction of the magnetic field. So please note down this question. So this question that is from the model question paper. So you have to find out the answer for this question. Okay, so try to find out the answer for this question. So here, which rule we can use here? So that is the right hand thumb rule that we can use. And direction of the magnetic field, the fingers around this current carrying conductor that represents the direction of the magnetic field. Next question. Observe the given figure, coil 1, coil 2 and the coil 3. If if key is connected to the coil 2 is plugged, in which the other two coils are current is induced. Why? In which of the other two coils more current is induced? Why? Yes, please. Here, in coil 1, the more current is induced because the number of turns. So when the number of turns in a solenoid that increases, the current induced that also increases. Okay, so that is the answer. Next question. List the properties of magnetic field due to the flow of electric current in a solenoid. This is the 3-mark question. What are the two methods of increasing the magnetic field in solenoid? Here, list the properties of magnetic field. So you have to list the properties of magnetic field due to the flow of electric current in the solenoid here. So the electric field that is similar to bar magnet, has north and south poles, can magnetize the other materials, uniform magnetic field at the center, magnetic field lines are there. So that is the characteristics of the magnetic field due to the current. Then what are the two methods of increasing the magnetic field in a solenoid? How can we increase the magnetic field in a solenoid? Yes, what is the answer? Here we can increase the magnetic field in the solenoid by increasing the number of turns. The stronger the more turns, the stronger the magnetic field. Same, the current increasing the current through the coil. A higher current produces when the stronger magnetic field for the same number of turns. Okay. Explain the right hand thumb rule. Explain the right hand thumb rule. Here, the right hand thumb rule states that if you hold a current carrying wire in your right hand with your thumb pointing in the direction of current, then the direction of your fingers curling indicates the direction of magnetic field lines around the wire. Okay. Next question. Explain the Fleming's left hand rule. Explain the Fleming's left hand rule. Yeah, so you have to explain the Fleming's left hand rule. What the three fingers indicate. Yes, next question. How do you trace the magnetic field lines around the bar magnet using the compass needle? Magnetic field lines do not intersect each other. Why? So here you have to write how do you trace the magnetic field lines around the bar magnet by using the compass needle. So that experiment you have to explain here. And you have to write the magnetic field lines so they do not intersect each other. Why? That you have to explain. Next question. What are the causes for overload and the short circuit in the electric circuit? What is the function of earth wire in the domestic circuits? So here, when the too many appliances are connected to the single socket, there is a chance of overload, and there are many reasons for the overload. When the voltage supply is high, that is also reason for the overload. And the short circuit in the electric circuit, when the two earth wire and when the two wires, live wire and the earth wire, when they are connected, so when the insulation is removed, when they become contact, there is a chance of short circuit. Okay. What is the function of earth wire in the domestic circuits? So earth wire, that already we have discussed. Please note down the question. Next, we are discussing the 4-mark questions. Okay. What is solenoid? Write the properties of magnetic field lines formed around the current carrying solenoid. What is alternating current? That topic is not there. Electric appliances having metallic body are connected to the earth wire. Why? Here, a solenoid is a coil of wire designed to create the magnetic field. When an electric current passes through it, often used in electromagnets and electromechanical devices. That is the definition of solenoid. Write the properties of magnetic field lines formed around the current carrying solenoid. Here, the field lines emerge from North Pole and merge at the South Pole. Inside the magnet, the direction of the field lines is from its South Pole to its North Pole. The magnetic field lines are closed curves. Magnetic field lines never intersect each other. Then, electric appliances having metallic body are connected to earth wire. Why? Here, the metallic body is connected to the earth wire, which provides a low resistance conducting path for the current. Thus, it ensures that any leakage of current to the metallic body of the appliances keeps its potential to that of the earth, and the user may not get a severe electric shock. Next question, again same question. What are the functions of earth wire? Is it necessary to connect the electric appliances having the metallic body to the earth wire in the domestic electric circuit? Why? Explain. So that is also a 4-mark question. Here, the function of earth wire is to provide the safe path for electric current to flow into the ground in case of fault, such as short circuit or insulation failure. This helps prevent electric shock, reduces the risk of electrical fires, and ensures the safety of both electrical appliances and users. Next question. How does overload and so many times the questions asked on this topic only, overload, short circuit and the function of the earth wire. So this topic only. How does overload and short circuit occur in electric circuit? Explain what is the function of fuse during this situation. Mention two properties of magnetic field lines. Okay, so these are the questions. Overloading occurs when too many devices are connected to the circuit, drawing more current than the circuit is designed to handle. This excessive current can cause overheating and of the wire and potentially lead to the electrical fires. And overloading can also due to the accidental hike in the supply voltage. So that is also due to the hike in the supply voltage. Then short circuit occurs when a direct connection is made between the 2 points in a circuit with different electrical potentials. By passing the intended load, this creates a path of very low resistance, allowing a large amount of current to flow suddenly, which can allow the cause overheating, damage to the components and the electrical fires. So that is the answer. The use of electric fuse prevents the electric circuit and the appliance from the possible damage by stopping the flow of unduly high electric current. The joule heating that takes place in the fuse melts to break the electric circuit. The fuse that helps to break down the electric circuit. Please note down the answer. How does a solenoid behave like a magnet? Can you determine the south and north pole of current carrying solenoid with the help of bar magnet? Explain. Please note down this question. Yes, one end of the solenoid behaves as a magnet north pole while the others behaves as the south pole. The field lines inside the solenoid are in the form of parallel straight lines. This indicates that the magnetic field is same at the points inside the solenoid. As shown in the figure, strong magnetic field produced inside a solenoid can be used to magnetize the piece of magnetic material like soft iron when placed inside the coil. The magnet formed is called electromagnet. Please note down the answer. Yes, so this is the diagram. So again, the same question, explain an experiment of drawing magnetic field lines around the bar magnet with the help of compass needle. Mention two properties of magnetic field lines. Yes. So here, using the compass needle, how the magnetic field lines are detected, that you have to explain. Explain the experiment to show that current carrying conductor experiences the force in a magnetic field. So this experiment we have discussed, so that you have to explain current carrying conductor so experiences the force in a magnetic field. So that is the Fleming's left hand rule that you have to explain with the experiment. How is simple electric motor converted into commercial motor? So this motor topic is removed. So we are not going to discuss this answer. Okay. Yes, dear students, these all questions, please, that will be helpful for your board exam. Please note down these all questions and practice the answers. Thank you.